So today we're on page 355, 47 to 65 odd. They're all story problems. And we have sort of moved past the original exponential equation that you guys dealt with. The y equals b times m to the x equation. Because it doesn't really make any sense in the real world. It makes sense mathematically when you're talking about sequences, where you're multiplying by 3 in a sequence or timesing by 1/8 or something. But in the real world, nobody compounds at the end of the year. It just doesn't happen. So we found another formula, the compound interest formula, which is future value is equal to the present value times 1 plus r over n raised to the nt. And I've tried to explain how this formula works. If your interest is compounded at the end of the year, let's say you have 8%. If you compound at the end of the year, you get 8% at the end. But if we compound twice a year, instead of getting 8% at the end, you'll get 4% halfway through the year and another 4% at the end of the year, but you'll end up earning more than you would if you got 8% over the entire year, because the interest in that first half will pay interest in the second half. So if you compounded 4 times a year, so every 3 months, you would get 2% interest after 3 months, and then 2% more after 3, and then 2% more after 3, and then the final 2% at the end. So the way the formula works is we are going to take our interest rate and we will divide it by the number of compounds. So you get a piece of the interest multiple times a year, and then instead of just raising it to the year, we have to raise it to the number of compounds times the year. Because if you compound 4 times a year, over the course of, say, 5 years, instead of getting interest 5 times, you'll get interest 4 times 5, which is 20 times. Okay? And then we talked about continuous interest. Continuous interest is you're always compounding. Every instant of every second, you're compounding. And that equation is it's the future value is the present value times the number e raised to the RT. The PERT equation. When would you use the PERT equation? Anything that grows or shrinks exponentially that is not financial. If money is in the bank, then you use the compound interest formula. For everything else, you use PERT. Even if, say, you buy a house and you want to track the interest or the value of the house, you would use PERT. Because that is sort of a pretend physical phenomenon. Right? Your house is either always gaining or always shrinking. So really, we use PERT for everything. So all that stuff you did last year, we were lying. Yeah, it's totally lying to you. You should use PERT unless you have money that is being calculated using a particular compound. So in essence, if it tells you what the compounds are, you use the compound interest formula. If it doesn't tell you what the compound is, then you use PERT. Okay? All right. Let's do number 47. Get this stuff out of the way. All right, number 47. In 2002, there were 7.1 million people living in London. If the population is expected to double by 2090, what is the expected population in London at 2050? Wow, that's kind of complicated. Now, the book gives a doubling formula. Don't even bother. We don't need to learn another formula. We're smart enough to figure this out. So, right, which equation are we going to use? We're going to use PERT. How come? It's a real-world application where the bank is not calculating compounds, and it didn't tell us a compound, so everything grows continuously except money in a bank. So right now we have 7.1 million times E raised to the R is unknown times, so 88 years. From 2002 until 2090 is 88 years. So I'm going to write 88R. Do I know what the future value is? It's going to be 14.2 because we want to double. What can I solve for here? What am I looking for? Well, this will tell me R. Is the question asking me what R is? No. So, we need to find R so that we have a rate so we can figure out how big the population will be in 2050. This is sort of a two-part problem. So the 88 is how many years it takes to double, and when I divide by 7.1, I'm going to get 2. And we learned in the past, time to double is just going to be 2 equals everything on the right side that doesn't include the present value. Now what do I need to do? I need to ln both sides. Why do I want to use ln? The ln of E is 1. So do you see now why our calculator has the ln button? Because E raised to an exponent is very, very common in the real world. Everything grows that way except money in a bank. So in a bank, you could, let's say, if you had 10,000 extra dollars, if you waited until after the bank opened and you put $10,000 in, and then right before the bank closed you took $10,000 out, you're not going to get any interest on that because they calculate interest at the end of every day. Well, yes, except you wouldn't be able to take the money out because they'd be closed. So yeah, that doesn't work. That's a good idea. But if you could use the ATM and then get to the next time zone fast enough, it might just work. Transfer, yeah, but in the United States, transfers are held up until the next business day. No transfers are calculated outside of business time, probably for this reason. So, I did hear a story about a lady who worked at a bank for 30 years and she never missed a day, ever. And it turns out that she was siphoning a little bit of money from different accounts and putting them in her own account. But in order to do that, she had to borrow and share in order to make everything look fine. So now, if you work in the banking industry, once a year, you have a mandatory 1-week vacation. Everybody does, the manager all the way down to the tellers. At some point, you have to take a week off just so they can see if you're embezzling any money. Because if you're not there to fix the books multiple times a day, then you'll get caught. So she never missed a day. I also heard of a guy who, when electronic banking started coming around, when you calculate interest, there's always that small decimal of the cents. And he wrote a program that would siphon off, that 0.1 cent or that 0.8 cent, and he would siphon it off and put it into his own account for every transaction. And as the bank had millions and millions of transactions, he made millions and millions of dollars, 1 penny at a, half a penny at a time. So, yeah, they both went to jail. All right, back to this problem. We're going to ln both sides and drop the 88R. ln of 2 is equal to 88R ln of E. But the ln of E is just 1. So now I take the ln of 2 and make sure you put the parenthesis in the right place and then divide it by 88. ln of 2, yeah, it's going to be a really small number. So the ln of 2 divided by 88. What does that tell us? That is the growth rate, which is just a little bit less than 1%. Now, when you're dealing with logarithms, logarithms are very, very temperamental. They're sensitive. And if you round the decimals in logarithms, then your answers can be off by quite a bit because they're not very thick-skinned. Logarithms are very, very sensitive. So I recommend that you push second answer as much as you can. Okay, and as long as you show your work, you'll get credit on the test, but it makes it more accurate if you use all of the decimals. So we now know R. What is that going to do for us? Now I can calculate the future value in 2050, which would be how long after the start? 48 years. I now want to do 7.1 million times e to the 0.0078 times 48. And there are two e buttons on your calculator. There's the one above the ln, which has the exponent in it, and then there's the one above the divide that does not have the exponent. So you can either do second ln or second divide, but the ln button has the exponent there. So we'll type in 7.1 e, and if you have the old calculator, you're going to have to put parentheses around your exponents. Second answer times, what do we say, 48? No, we're going from 2002 to 2050. So the answer is 10.4 million people. Okay. So you are going to use the PERT formula for pretty much everything until you get to the compound interest questions like 57. And remember, when you plug rates into these two formulas, you don't do the 1 plus rate anymore. So if you're growing 6%, you don't type in 1.06, you just do 0.06. And that's true for both the compound interest formula and the PERT formula. The other thing is, if you are going down, your rate must be negative. So if you look at number 51, radioactive decay, R is going to be negative. So if you're dropping 3.5%, it would be negative 0.035. All right? Okay, get to work.